So the sine law is a formula or a law that tells us how we could find an unknown angle or an unknown side length for a super specific set of information that we're given and a super specific set of information we're trying to find. So the formula for the sine law, remember, it's sine A over A equals sine B over B, which equals sine C over C. So these letters A, B, and C, they're all just parts of the triangle. So the capital letters, the stuff we're taking the sine of, those are all angles. And these lowercase letters are the side lengths that are opposite to those angles. Okay, so for example, in this triangle here, lowercase a, that means that opposite to lowercase a must be uppercase a, because that's the angle across from a. Okay, so for the sine law, let's check out this triangle and see if we can use it to figure out this a value here. So we're given this 12, this 40 degrees, and this 11. So notice that the order of information we're given is side, angle, side. Okay, anytime we're given side, angle, side, that's an indication we're going to use the cosine law. And the reason for that is, let's see if we can use the sine law. So 40 degrees is the only angle we're given, so we can't immediately compute these other two angles because we can only use that trick where we do 180 minus the angles if we have two angles, right? So if we knew this was, say, 50, we would know that this angle here, that's a bad example actually, if this was 60, we would know this would have to be 80 because all of these have to add to 180 degrees. But we don't know what either of these are. So if we want to use the sine law to find an unknown side length, we need to know two angles. So if we're trying to find A, we would have to know A, which we do know, which is 40, but we'd also have to know B. So since we don't know one full pair, we have to use the cosine law. And the cosine law, I'll write it out here, is A squared equals B squared plus C squared minus 2AB cosine of capital A. Okay, and the cosine law can be rearranged in any particular way as long as the thing we're squaring on this side that's isolated matches the letter of the angle that we're taking the cosine of. Okay, so we can say B squared equals A squared plus C squared minus 2AC cosine, and remember these B's have to match, so cosine capital B. And this is the same as C squared equals A squared plus B squared. So this right here is a Pythagorean theorem, except we have to subtract this minus 2AB cosine, and remember the cosine we're taking is going to be the capital C because it's the same letter, just capital, of the lowercase side length on the other side of the equation. So in this case, we're looking for A, and we know capital A. So if we're looking for A and we know capital A, we're going to use this first equation. Okay, because in the other equations, we would need to know capital B or capital C, which we don't. So the only angle we actually know is this capital A. So we're going to use this equation. So A squared, we still don't know what that is. B squared and C squared, it doesn't matter which one because you're adding them here and you're multiplying them here. So the order at which you put them doesn't matter at all. So I'll just put 12 squared first, plus 11 squared. So this is our B, this is our C, right? Order doesn't matter. Minus 2 times 12 times 11 cosine of, remember, the thing we're taking the cosine to, often it's the only angle we have, but if we have multiple angles, it's going to be the angle that's opposite to the side that we're trying to figure out, or the side that's isolated already on the other side. So lowercase a opposite to that is 40. In this case, it's the only angle we know, so it's not too hard to choose. right? So now we just use our calculator. 12 squared, let's see here. 12 squared is 144 plus 11 squared. That's going to be 265. Okay, so 265 minus, okay, minus 2 times 12 times 11 times the cosine of 40. So that's going to be 202.24. Okay, and once we subtract those, and remember this is a squared still on the left. So if we go 265 minus that, it's going to be 62.8. And if we want just a, right now it's a squared, a is going to be the square root of 62.8, which is 7.92. So I'll just go 7.9. And if we go back up here, that makes sense, right? Because this is 11, this is 12, and this a looks like it's about 2/3 of 12, right? 2/3 of 12 is 8. Our answer is about 8, so that makes intuitive sense, right? So the cosine law, it's really when we either know an angle and we're looking for its opposite side, or we know its opposite side and we're looking for the angle, right? But if that's not the case and we're looking for B or C, we're going to have to use a quadratic formula to solve for B or C, and that's not an optimal situation, right? Because typically, if we're looking for B or C, we're going to be using the sine law, because remember I said this was B here, so that means this would have to be capital B. If we were looking for this B here, we would have to know this angle, in which case we would also be able to figure out this angle, and from that we can just use the sine law to figure out B, right? Because we already know this is 11, so typically we don't use the cosine law to solve for B or C. It's only like the isolated side that's being squared or the angle. There's exceptions, of course, but that's typically the case, okay? Let's look at this next question here. So in this case, we're not looking for a side length, we're looking for an angle. So you'll notice I'll call it c squared on the left now. It doesn't matter. Okay, it doesn't matter what you call A, B, and C, unless they indicate it in the question. But notice how these always have to match, the C and C. Okay, so notice that we know all three side lengths. We know A, B, and C. And this angle here is the only thing we don't know, right? We're trying to solve for this theta. So actually, instead of C, I'm going to put theta, because in the question, they didn't put C, they put theta. Okay, so anytime you have a triangle like this, and you have all three side lengths, you can use the cosine law to figure out any of these three angles. So if you call this lowercase c, this will be your capital C, you can solve for that. If you call the 14 lowercase c, you can solve for this here and call it uppercase C. And if you call this lowercase c, you can solve for this and call it uppercase C. So the order that you put the thing on the one side that's isolated being squared does matter. So if you have all three side lengths and you put the 14 squared alone on one side and these as your A and B, then you're going to find the angle opposite to this 14 using the cosine law. Okay, so if we're trying to find this cosine theta, so the cosine of this, right, or just that angle itself, the opposite side to it is going to be our lowercase c. So that means that 28 squared is going to be our c squared. A squared and b squared, like I said, it doesn't matter. Once we already picked our c. Okay, so 14 squared plus 18 squared minus 2 times 14 times 18, right, minus 2ab, times the cosine of theta. So this takes a bit more algebra here. 28 squared is going to be 784. Okay, that's going to be equal to, so 14 squared plus 18 squared is 520 minus Okay, 2 times 14 times 18, that's 504. Typically, we would just do 504 times the cosine of theta, except we don't know what the cosine of theta is. We don't know what theta is. So we have to leave it as just 504 cos theta because we don't know what the actual value theta is. And right now what we're going to do is we're going to move this 520 over to this side. Okay, so if we subtract 520 on both sides, right, we're going to get 784 minus 520. That's going to be 264. So 264 is going to be equal to negative 504 cos theta. And if we just want to solve for theta, we're going to have to get cos theta on its own first. So we're going to divide both sides by negative 504. Okay, so cos theta is going to be equal to 264 divided by negative 504, which is negative 0.52. Now theta, that's going to be the inverse cosine of negative 0.52. So let me just do that in my calculator here. That's going to be 121.6 degrees. Okay, so obviously I didn't draw this to scale, but if this was to scale, this angle would be obtuse, right? It would look something like this. So this would be 121 degrees, I guess 0.6. And like I said, I didn't draw it to scale, but if it was to scale, this angle would be more like this. Okay, so this would be more obtuse, not so acute. Okay. So that's how you can use the cosine law to figure out an angle and a side length. Like I said, if you have all three side lengths, you're going to be using the cosine law. And if you have side, angle, side, you're also going to be using the cosine law. Sine law is when we have angle, side, side, right? Or we're looking for things in pairs, but cosine law, very specific case. So the formula, right, as you can see, the formula, as you can see, is a lot different. So these are the two formulas. They're nothing like each other. The cosine law is kind of an expansion on the Pythagorean theorem, right? We can see this kind of like something squared equals something squared plus something else squared, that kind of thing. But yeah, that's the cosine law. That's kind of an essence of the different laws. And I'm going to do lots of questions where we're using these two laws to figure out real world problems. So I hope this was helpful, and I'll see you in my next video.